Whenever people think of a chiller, this particular device is all they think of. This is only one part of the system. All of the systems have to operate properly in order for the chiller to function. We are going to review a negative pressure chiller during this video. We'll start with the chilled water pump. This is what moves the chilled water fluid through the system. This provides all of the moving and transferring of heat that's absorbed from the phase change of Freon. For this plant, the heat is then transferred to the service water system and then to the main cooling water source. With varying sizes of chillers, you have to have the correct size chill water pumps to get the proper flow and remove the right amount of heat. Too much or too little is a problem. The job of the engineer is to pick the right size pump. In the overhead, we have an expansion tank. The expansion tank is a volume that allows makeup for normal temperature fluctuations and leakage. It is also elevated to allow better suction pressure to the pump. The cooling coils is where the chilled water moved by the chill water pump is pushed through the coils and the air flowing across the coil is cooled. That is what provides the cooling for the control complex. This is the area served by this chiller. Let's review the chiller. This particular chiller is a low pressure appliance as described by the EPA. I'm going to break down the flow within the chiller. We will start with the compressor itself. This particular model uses a centrifugal compressor. On the inlet side, there's a large impeller. Prior to the impeller is a set of inlet vanes in an annular configuration, which the control system will open and close to regulate the inlet volume into the compressor at the impeller. The hot compressed gas is then discharged, so we have to cool and condense that gas. This is one of the phase changes that occurs in the machine. That gas exits into the condenser. The condenser contains a tube bundle that runs the length of the machine. Different machines have different design tubes. Some have fins on the inside, some have fins on the outside. Usually they're externally finned. The tubes are periodically cleaned to remove deposits on the interior tube surface. Heat exchanger tubes also have non-destructive examinations, referred to as NDE, performed on a periodic basis per the plant's preventive maintenance program. Service water supplies the secondary cooling water for the condenser, passes it through the condenser tubes and back to the SW system. This condenser has a control valve on the discharge side. This valve is a pneumatic valve which regulates the discharge volume of the condenser. This ensures we extract the proper amount of heat. This machine has a mixing box. It looks like a small box, which you can see here. There is an orifice plate inside which restricts the amount of liquid refrigerant passing through. This is the metering device. As it passes through, it changes pressure. After the refrigerant goes across the pressure breakdown device, it goes into the evaporator section. As you can see here, all of the lower portion of this machine is insulated to minimize the heat transfer from the environment and reduce the amount of sweating on the steel surfaces. The evaporator is under lower pressure where the refrigerant boils and removes the heat of the chilled water system. This chilled water passes through the tubes in the cooler/evaporator. This is the second phase change. Once the refrigerant passes through the evaporator and completes the second phase change, it is then routed back into the suction side of the system. This large insulated pipe is the suction to the compressor. This completes the refrigeration cycle. Different machines may have different devices within that loop, but the cycle for the negative pressure machine remains the same. There are many controls required to allow the chiller to operate properly. Many of these functions are controlled from this panel. These displays are the main parameters that an operator would need to see. You have oil pressure, condenser pressure, and cooler pressure. There are many other parameters to validate the performance of the chiller, but these are the basics that an operator needs to log and monitor. Two of the operations we control are the iris, that's the compressor inlet vanes I talked about earlier, and the hot gas bypass. The hot gas bypass is a unique function. Because of the design basis requirements, the chiller must operate over a wide range. If you have no load on the machine, the cooler pressure will drop to a point where the machine can't function. Operating under very low load may cause the chiller to trip. These machines are not good at starting and stopping, so you want to keep it running. In order to keep it running, we use the hot gas bypass device. Let's review how the hot gas bypass system works. The entrance side is tied to the condenser inlet section where you have a higher gas pressure. A butterfly valve, this is not really a metering device, we are working with the gas at this point, not a liquid, controls the flow back into the cooler. This artificially raises the cooler pressure, preventing unnecessary cycling. The refrigerant filters ensure gas cleanliness. They remove contaminants and foreign material from the refrigerant. Contaminants within the refrigerant system will reduce the longevity of this machine. Any foreign material will cause problems, whether from a physical debris or chemical introduction into the system, which will form acids and will corrode the inside of the machine. The windings in this motor are very susceptible to dirty refrigerant. Only clean, dry refrigerant and the appropriate refrigerant oil should be in this machine. Let's review the oil system. The oil circulation system of this machine has 4 oil pumps. The auxiliary oil pump is a motor-driven positive displacement pump. The second pump is called the jet pump. The pump operates by oil passing through it, spinning up a small ring, boosting the output pressure. These 2 pumps are used on startup. The auxiliary oil pump and jet pump pre-lube the machine. We have 2 pumps within the compressor itself. These are small volume, high pressure pumps driven off the shafts of operating components. These maintain stable pressure during operation. There is an oil filter that purifies oil during operation. It's also one of the filters you'll need to take care of on your periodic maintenance. We will discuss periodic maintenance and the potential pitfalls in a later section. When these machines were originally designed, a certain amount of area and leakage was expected, which was compensated for by the addition of a purge unit. Non-condensables are gases normally found within the atmosphere which will not condense during normal operation. This purge unit takes refrigerant along with non-condensable gases, then condenses the refrigerant out of the non-condensable atmospheric gas. The liquid is returned to the refrigerant system and the non-condensable gases are discharged to the environment. There's one last system to discuss. The oil eductor on this unit is in continuous operation. It removes oil from the extreme lower levels of the shell and returns it to the crankcase. There is also a filter in this system which removes particulate and moisture.